So welcome to my talk. It's called Metaphors We Compute By. My name is Alvaro, and I'm AllSound on Twitter. If you want to know more about me, I wrote that article, How I Went from Selling Food in the Street to Working in Tech. It's on Medium, and you can read the whole thing there. So I'm not like, as we say in my country, I only went to university to use the toilet or the restrooms. That's the only reason why I went there. So yeah, anyway. This article is already published by the EXPLANATOry and also the printed version, so you can read it there if you feel like going to the next track. So the year is 1980. This is like a year before I was born. And there was a book published by Lakoff and Johnson. It was called Metaphors We Live By. So you can see that my title is not really that original. Actually, this book was so influential that a lot of people came up with metaphors I don't care what else buy. So yeah, there are a lot of books like that. And the main idea of this book is that metaphor isn't just a matter of poetry and rhetorical flourish, as it was understood before. They say that metaphors dictate how we behave in the world, how we think, and so on. And because they were cognitive scientists, they wanted to study the brain, but there weren't many voluntaries to open their brains and let them see what was inside. They say, OK, let's use a proxy. That proxy is language. So that's why they got into getting into the metaphor thing. And just to give you an example, OK, so they say metaphor dictates how we think, how we behave, how we perceive, and how our conceptual system is built. But as an example, they say that argument is war. This is how we humans in general, we understand when we argue with another person, our frame of work is war or battle. So because we understand it that way, we say that your claims are indefensible. He attacked every weak point in my argument. I demolished his argument. I never won an argument with him. His criticisms were right on target, and so on. Because we understand argument as war, whenever we start arguing, we want to destroy the other person. Just like go to just shout outside that Emacs is better than VI, or that you should use tabs and spaces, and you will see what happens. Anyway, the thing is, yeah, they ask, because that is the frame of mind when we get into a discussion, that's what happens. And they ask, what will happen if argument will be seen as a dance, that we need to collaborate to reach a common goal? How are we going to see the other person, and how are we going to treat them? But I see you're not convinced. So when somebody's not convinced, we talk about politics. So, I mean, just think about the United States. I'm kicked out of the conference. No, just think like they want to kick some immigrants, but the immigrants they want to keep inside, they are called dreamers. That's a really nice way of speaking of people you want to keep in. You have a really nice thing to say. They're here for the American dream, or whatever it is. Or in Spanish, the ones that arrive in Latin America, they are conquistadores, conquerors. They are not really nice sounding words. But in America, they are settlers, because they just came there. And the native people say, yeah, you can just settle here. I go to the other side of the river and to the other side of the river. And at some point, the natives were on the MIT license. They ended up using BSD license. But you know what happens when you cross the Mississippi, right? Anyway, more into the point, there is a BBC article that says how metaphors shape women's lives. The article is really interesting. But it has a paragraph that says that there was an experiment where they asked two groups of people to analyze the statistics on crime. Some of them had the metaphor that there was a wild beast preying on the city, and another one that there was a virus infecting the city. The wild beast people, they really wanted harsh punishment for those criminals. And the other wanted more like, let's try to reform them, help them, stop being criminals, whatever. Thing is, when they ask these people why you want to punish them, because the data, look at the data, both have this exact same data. One had the beast narrative, the other had the virus narrative. To keep going, there is a nice book from the 90s called Feminism Confronts Technology by Judy Weichmann, I guess. And she studied how language started changing the way technology was seen in the 80s, and how women started to be pushed out of IT. And it's because we changed what hard and soft meant. So because I'm a man, I'm a macho, I need to show my testosterone, whatever I do, testosterone.js, which you probably can search on NPM, I don't know. And they started using like all this hard language that this is really how we identify as geeks. You please stay out of my realm. And she keeps going on that book, on this study by this person, Coburn, explaining how language was used in a way that didn't make it so friendly anymore for women. That's research there. I can see that you're still not convinced, and I can see if I speak here, it's probably louder anyway. Human resource management. That's a really nice metaphor for maybe another industry. But do you think you are just a resource as a programmer that a manager can come, replace you, put you there, and keep working? Like we people are usually not resources, but when you have this metaphor in mind, and the manager probably has no idea too much about what programming actually is, they think they can replace you, and it doesn't really work that way. But when you work on that framework, then yeah. Trigger warning. Metaphors, there are conferences on the other side of the pond that they like to give platform to racist people. And when people complain to them, they defend themselves instead of taking the criticism from the community. And one of the articles they brought was called Wrestling with Inclusion at whatever the name of that conference. And I wonder, why are they wrestling with inclusion? Why don't you just work together with inclusion or talk to inclusion? I don't know, but why you need to wrestle with inclusion? Just questions to think how we talk, how we speak, how this make us behave one way or another. But I'm pretty sure you're here to talk about computers. So I was not going to keep my rant going and going on that. Now my rant took another diversion. You probably saw that film, Hidden Figures, about the women that helped NASA put men in space. They were computers. And at some point, somebody came up with this big machine that could actually automatize all these things, and they were just called, well, automatic computers. And with the passage of time, the automatic word got dropped, and now computers are these things we use every day. And in another article by Sadie, I can't remember her family name, sorry. She has a book called Zeros and Ones about the influence of women in computing. And she said at some point when working with von Neumann, it was the wife of von Neumann and many others, there were computers building computers, like actual human computers building the original computers. So why does it matter that this is a word used for one thing and then used for something else? Because metaphors, they enable understanding. We use metaphors all the time just to explain things. Today, in the talk about how to build this theater in Germany, he said that the sound was transparent and clear. Usually, sound is transparent, I think. But we use that. I mean, I'm not taking from his talk. Actually, it's a really good example of how we use all these concepts to explain things that we don't really know how to explain. So metaphors, they enable understanding, but a metaphor is not a one-to-one mapping of the thing we are trying to understand. Like when Shakespeare says Juliet is like the sun, we don't understand that Juliet is some sort of atomic bomb all the time blowing up, and I don't know. We just understand that Romeo's life goes around her. He depends on her for being alive, whatever. Like she's the reason for him to be alive, I don't know. But we don't understand that Juliet gave him cancer, like that's, or skin cancer, sorry. Because it's not a one-to-one mapping. It's just we see patterns on a domain, and we translate those patterns to a different domain. And this is analyzed in this book called The Geometry of Meaning, Semantics Based on Conceptual Spaces by Peter Gardenfors. He's from the Netherlands, I think. And he said, okay, why can't I use topology to understand language? Because that's what people ask when you have a PhD grant or something, I don't know. And he says that metaphorical mappings, they preserve the cognitive topology of the source domain in a way that is consistent with the inherent structure of the target domain. So metaphors, they transfer information from one conceptual domain to another. And what we transfer is a pattern rather than domain-specific information. The atoms and the skin cancer, they stay there. We understand what we need from there. So a metaphor can thus be used to identify a structure in a domain that will not have been discovered otherwise. I will show a lot of examples of this later on the talk. But that's what metaphors are so useful, because they show, okay, those things in that domain, they actually look like transparent and clear. And then, okay, that kind of sound. Yeah, I know what you mean. And I think this is completely not the graph, but there is no paper to back this up, let's say. I think we are doing the whole time this graph isomorphism problem in our minds. Like we see a pattern somewhere, we see it that way, and then we manage to match it. And researchers on conceptual blending, they say that our brains are actually pretty advanced at discovering patterns in things compared to computers that are made for computing. A computer is a really good tool to make really fast calculation, but it's not a really good tool for discovering all these patterns that we see and that we manage to ignore when we see those analogies, let's say. They put an example in that book like Margaret Thatcher, she will never have won in the United States because the unions in the United States are stronger, something like that. She has the example, stronger. Another metaphor to explain how unions work. But he say, Margaret Thatcher is a prime minister. They don't have prime ministers in the US. The unions here are not the same unions they have in the US. Margaret Thatcher won't become a citizen of the US and blah, 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 blah. All these things, we manage to keep them away, and we understand what they mean by that she wouldn't have won there, whatever that supposition could mean. Because with this translation or transport of knowledge from one domain to another is how metaphor creates new knowledge. Actually, metaphor in Greek, I think it means to transport. Maybe there's a Greek person here that can correct me. But yeah, they transfer this thing from one domain to another. But they also obscure understanding. And this was a problem, for example, when they tried to create the first telegraph. Because telegraph means like far writing. And people were trying to create actual far-writing machines. They didn't understand that you could encode things like in Morse code and send this over the wire, the code on the other end, and so on, because Claude Shannon wasn't born like in the 18th century, let's say. So it was because Braille had the sign for blind people, then Morse started thinking with these ideas of the Morse code, and together they came up with this whole code and say, okay, we actually can encode language in a different way on how we write it and how we speak it, let's say. Before the telegraph, you could have like 1 bit of information with a fire over on the top of a hill, like similar to what they do at the Lord of the Rings, let's say. But back to the metaphor, because of people were so stuck with the metaphor, they didn't understand that they could detach from the actual writing part. And the telegraph was like the cool invention of the time. That's one of the reasons why the newspaper here is called the Telegraph, because it was the cool thing to have. It was when they started having weather reports, because people in Liverpool could telegraph down here and say, hey, it's raining here, the clouds are moving south, you will have rain in 3 hours. They started catching people that were stealing stuff, because before the telegraph, you just got into the train, good luck catching me. Now this guy with a beard and a square t-shirt or shirt is there, it will be in, I don't know, Paddington in 20 minutes, catch him. That was all enabled by the telegraph. That means like tools, they change how we behave, how we work in the world, let's say, how we understand the world. And there's a quote by Nicholas Carr. He has a book called The Shallows that explains how the internet is shaping our minds. And he said, like, sometimes our tools do what we tell them to. Other times, we adapt ourselves to our tools' requirements. In this case, metaphors are the tools of thought. Depending on which metaphor we are using is how we are adapting ourselves, or if are we even able to see a solution for a problem. I will also show examples of that. So, metaphors and code. There is a really great paper from the 50s that I think is one of the best unknown papers. Why? Because this paper actually came to light because somebody started scanning the Donald Knuth's archives. Before that, it was probably lost somewhere, and Knuth doesn't even know who wrote it. He knows who sent the letter to him, but we don't know who wrote that paper. Maybe if you are here, raise your hand. But the cool thing of this paper is that the idea this programmer had back in the 50s about what was good code. Yeah, like the British and tea time. I don't know what that means down there, but yeah, some metaphor he was trying to show. Anyway, he says that, or she, that to program is to write to another programmer about our solution to a problem. That's what we do as programmers. If you think you're coding for a computer, then probably this talk is not for you. If you think you're coding either for your future self or for your colleagues, then this is where I'm trying to get with this talk. And Knuth says actually like a nice measure of a good program quality is how long it survives that I can still understand what this program is doing. That's what this person argues on that paper. And you probably know this quote as well. Programs must be written for people to read and only incidentally for machines to execute. That's from Structure and Interpretation of Computer Programs. And also recently, I found a paper where David Wheeler, I think he's British, when he introduced the subroutine back in the 50s as well. And he says, basically, the subroutine is not necessary. We don't need subroutines for the programs to be actually run. That's like the conclusion of the paper. We are doing it because we want simplicity of use, we want correctness of code, we want accuracy of description, and all complexity should, if possible, be buried out of sight. That's why we need subroutines, to make code easier to understand. It's not going to do anything else. Like, I can just write the code in a whole file and run it, it will be fine. Come back, stay there. That's from his book. He wrote the first programming book in history, I guess, or public book. And a curiosity is that woman is the first programmer ever pictured in a programming book. And you can see in the description there that that's the actual library. That's your metaphor of library of programs or subroutines. They are explaining that from there, they can take the subroutines and load them into the computer, whatever. Yeah. So metaphors and code, like, how do we go for all these nice ideas, or how do we actually apply it into the code we write every day? I think types are these characters that tell the story in our programs, are the characters that explain how our programs work. But if the Haskell people in the crowd, Scala people in the crowd are really, woo, this is my talk. I'm not talking about those types, sorry. And more about this old paper from Barbara Liskov. She says, programming with abstract data types, like how you will build your user, your queue, all these entities that make your program. And actually, back in '74, I think, when she wrote that paper, she had to argue that you actually should do abstraction and actually encapsulate the code. The industry was kind of getting out of, yeah, it's fine to use functions or procedures. We don't need to just write go to everywhere. And now she came with this idea from outer space, like we can use abstraction. Yeah, there is a talk she gave at InfoQ, I think, when she explained all these bits of history, how she had to kind of fight argument for these ideas. And the point is that without types, we just have operations on stream of bytes. For a computer, it doesn't really matter if you have a user or a bunch of bits. And actually, von Neumann, because there is always this discussion of who is a real programmer? A real programmer types in Emacs, I don't know. For von Neumann, a real programmer will write in byte code, because this assembler thing is just a waste of time. Assembler. So, I mean, no, we need types. We need a thing that we humans can work with. And one example is like when we choose the right data structure. If we need to keep track of a bunch of users, we can just put all of them into an array, and that will be perfectly fine. But if in the description they say, and this user had to be unique, and we will have used a set, that information is already encoded in the set. That data structure is telling me about uniqueness of elements. If I use a linked list, I may mean another thing, like how you can traverse those items. The queue gives me the information first in, first out. The stack is the opposite. And can I use an array for any of these use cases? For sure, but all these data structures, they're giving me more explanations on what this code is actually trying to do or achieve. Because I think the explanatory power of a program is the measure of its own elegance. And data structures, they have this kind of explanatory power, and they can help us get some sort of cognitive leap when we are trying to approach a problem. Just think about what I just said, approach a problem. That's completely metaphorical. Problem is like problem I think in Latin is the same root as object in Greek. And it's when somebody throws something at you and you need to deal with that. And Flusser, which is a philosopher from Czech Republic, I think, he explained all this relation between these two words. So object, problem-oriented programming. Anyway. Task scheduling, don't ramble too much. Task scheduling, like I can try to explain to you, like, yeah, we need to process these items as they come into the system. We need to try to keep the order they enter the room or blah, blah, or yeah, just use the terminology of queuing theory. When we understand our problem is a queuing theory problem, not only we have the whole vocabulary related to queuing theory, we actually have the theory behind it, the mathematical theory that can help us solve the problem much faster, reason about it, use math, and so on. The same with route planning. If you are like very new in the field, let's say, I don't know, you never heard about graph theory, and somebody tells you to draw a route or find a route from here to, I don't know, Paddington, it will be quite hard to solve this problem. But when you see that the map of the city, which is already an abstraction of the actual city, can be abstracted even more as a graph, you have the whole power of graph theory. And this is what Lakoff calls conceptual metaphors. Like the same can be applied with rotation and group theory. Rotation is a way of seeing, or symmetry, a way of seeing group theory. And all these things are metaphors of different mathematical concepts. It's not just words replacing words. We can also work at this level with metaphors. And I think the most interesting one comes from the database replication world. Back in the 80s, they tried to implement a new way of replicating data. I think it was for Xerox. And they came with the idea of rumor mongering, like on the seminal paper on this kind of gossip algorithms. So when you will do gossip, I am a computer. I tell this new set of information to two computers. This one is spread to other two, and so on. Kind of like rumor is spread. The problem with this is really hard to reason about rumors. Yeah, maybe we South Americans are used with the telenovelas, but not everybody has telenovelas in their daily lives. So rumor mongering, not so easy. Anyway. But they find out that actually this mapped really cool to the concept of epidemics. When they saw there was a relation with epidemics, there is also this other book, The Mathematical Theory of Epidemics from the 50s, and they could use all those maths to model and like check their algorithms, check that they were actually going to converge into whatever replication they wanted. So here you see, finding the right metaphor. Maybe epidemics is not the easiest one to explain things. Maybe rumor mongering is a bit easier to say how data will be spread out. But when we need to actually, when the purpose is to reason about it, maybe this one is much better. So I don't remember, no, it's not from this conference, but there was an argument today on Twitter, as it happens, there is always argument on Twitter, about category theory. And I think it was Jaron Minsky, yeah, category theory, saying that concepts like mappable or mappable or whatever you pronounce that are easier for beginners. And then there was this other person saying, no, we should use functors because this is a well-defined mathematical entity. Sure, but this is really easy to understand. This is really easy to work with mathematically. Maybe mappable, or however you pronounce that, is really easy for me to get it as a beginner. I will show you an example later of a similar mistake I was doing. But then when people are using it, when they fall in love with it, okay, go with the functor notation and throw all the math book into their heads. But maybe we need to find ways to get the concepts across and then keep growing the thing. So everything is a metaphor. I don't believe you. OK, let's grab this from distributed system metaphors. Whenever nodes need to agree on a common value, we start consensus algorithms to decide on a value. There's usually a leader process that takes care of making the final decision based on votes it has received from its peers. Even received, decision, all these are takes care. This is all metaphorical. Then it continues. Nodes communicate sending messages over a channel, which might get congested due to too much traffic. This could create an information bottleneck with queues at each end of the channels backing up. And finally, these bottlenecks might render one or more nodes unresponsive, causing network partitions. Again, is the process that's taking too long to respond dead? We won't know unless we set a timeout, blah, blah, blah. It's just metaphors on top of metaphors on top of metaphors. Maybe when you are really good at understanding those mathematical concepts, it's because you already built this scaffolding of metaphors. Lakoff has a book called Where Mathematics Come From, and he explained like when we understand things like the number line, that's a metaphor, and then we keep building on top of that until we get to imaginary numbers and things like that. So there's metaphors literally everywhere, like here. Who doesn't love a good buzzword in their breakfast? So buzzwords, you can guess which one that is. Containers, right? Why I bring this one up? Because I think containers, as a metaphor, has a really cool story, a really nice elevator pitch. Let's say that I can bring elevator pitch again. That's a complete metaphor. I'm not getting any of you into an elevator. So containers, they are standard. They can be shipped anywhere. They can fit on train, ships, and trucks. They can be stacked. They can be reused. We can understand that. We like that. It's really easy to explain, to talk about. We understand that we don't need to fill a ship full of containers to do an actual shipment. We get it that the metaphor doesn't stretch that far. And we have a really nice thing to have a story about this new technology. Anybody can go and sell containers, even if nobody knows what containers are actually about. I have no clue, by the way. Then, will this happen in the future? Will there be like a the guy from the Comet, Halley diving bell? Like he created this thing to go under the sea to recover wreckage from shipment. Will there be any company that will come later and do a recovery of all the garbage we created with the container industry? Who knows? That's your free startup idea. Don't credit me. And another one is microservices. When I was reading this paper, let's say, or this article, the whole time before I was an Erlanger, yeah, I know, I've been there. I suffered that period of my life. Sorry. Now, and then when I was reading this paper, I was all the time saying, this is Erlang. Every single paragraph, this is Erlang, this is Erlang, this is Erlang. They say, okay, we have decentralized governance, we can have monolith versus microservice. Just think of the power of the word monolith. That's like showing the Austrian H guy into a discussion, you know, the one from 1939. If you throw monolith today, you won. Like, you are building a monolith, boom, okay, end of story. This provides isolation, collaboration, small is better, big is cumbersome, David versus Goliath, all the whole story, ooh, microservices. And yeah, I was wondering, is this Erlang? And in the last footnote of that article, you can check it online, they say, in another direction, one could argue that microservices are the same thing as the Erlang programming model, but applied to an enterprise application context. So are you an Erlang fanboy that came here to cry about how Erlang didn't work? No. My question is, what's Erlang elevator pitch? How do you explain the good things about Erlang? I'm sorry. In like really short time. We make programs that don't crash. Which programmer will tell you, yeah, I write software that crashes? I'm pretty sure nobody will raise their hands. And we write reliable software. Yeah, me too in PHP. It's quite reliable, you know? And it's because I came from the PHP community into the Erlang community. And many of these arguments for me were like, I don't care. But the binary syntax was pretty cool. So that's what got me more into Erlang. But anyway, what's the Erlang's elevator pitch? Readable code, yeah. But Mike, who will tell you that they don't write readable code? It's what? They say there is no GC poses, there are none in PHP. So, come at me, bro. Yeah. In the, what is the saying? No, I won't say it, but yeah. Yeah, like in the world of the blind, the one-eyed man is the king, right? That's an analogy. Maybe not that nice, but yeah. That's me when I defend PHP. Anyway, the thing is, first get people to understand things, then explain how things actually work. You probably know me from RABBITMQ, and when I was going around talking about RABBITMQ, people came to me and said, hey, but RABBITMQ is a job server. No, it's not a job server, it's a messaging server, because a message is a higher abstraction than a job. When you use a job, you are limiting yourself about what can you do with Rabbit, this amazing product. Dude, chillax, I don't care anymore. This other tool is much easier. Because, yeah, let's allow people to use Rabbit or Kafka or I don't care what, as whatever they think it is, and then we keep putting the other layers of abstraction. Is it a functor? Is it a thing I could do a map on? I don't know. At least I understood it. I managed to use it. And I think job server, yeah, it worked for me. Sadly, I understood this too late. Conclusion. I think we need to master the art of metaphor selection, master the art of meaning amplification, and understand that our program is a metaphor for the solution we found. We had a problem, we found a solution, and that is materialized, let's say, into that program that we found there. Those are the references, because I know you are all eager to go and read that. I recommend Metaphors We Live By. It's one of my top books ever. If you don't want to get in the whole theory very in detail, then I is another, The Secret Life of Metaphor and How It Shapes the Way We See the World. That one is really interesting. Yeah, and that's the paper I mentioned. And The Information and History as a Theory of Flat. That book is really cool about the story of information. Credit for the pictures, and thank you very much.
So we have, yep, okay. So we have time for some questions.
Thank you very much. Lots of food for thought. I remember a paper I read many years ago that said the best programmers are the ones who have got many different abstractions in their head, and they can apply them in for the particular problem they want to solve. Actually, I think it was Bill Wolfe who had written that paper. But somehow it sounds related to the idea of the metaphor, to find the metaphor. I don't know. What are your thoughts?
Yeah, I think whenever we abstract, or actually, in a way, that's what Lakoff shows in this other book, Where Mathematics Come From, I think, is that abstractions are metaphorical in a way, because we find these patterns that actually, or put in another way, there is this story by Borges about this town that wanted to make a very precise map of their city. And at some point, it went completely useless. So an abstraction, it will always take some things, and some will be put aside. And I completely agree, yeah. Having many abstractions that we could apply to problems will make us much better programmers.
So you make a very powerful argument of metaphor being important to programming, or maybe even you would say is programming. I don't know how you go there. But does that point to a gap in the education of programmers? Because I don't think kind of critical thinking about metaphor or reading any of those things on your nice reference list is part of many people's CS education, if they do have a formal one.
Okay, as they say, I'm really glad you asked that question. He's planted by me from before the conference. No, actually, I've been thinking as what's my next step from here, and I stepped into the trivium, this idea of I don't know how many ages ago. And in the trivium, you have grammar, you have logic, and you have rhetoric. We focus too much on grammar of languages, on the logic we use our programs on, but we don't care about how to get the message across, which is that what rhetoric brings together. And actually, in the definition, they say grammar is input, logic is processing, and rhetoric is output. So it's completely, in a way, metaphorically related, let's say, to our field. And I think rhetoric is completely put aside. Like, we just don't care about that part. Because the problem with this way of communicating is as long as a computer manages to execute it, it's good enough most of the time. We don't put emphasis on the human side of programming. So we should, I guess. But, yeah. I think there was, oh no, no. Not the kid, Andre.
Have you found that the way you express yourself at work, write stories, talk to your teammates, anything like that has changed due to, so not trying to use aggressive language, you know, wrestling with or etc. Have you made any changes, and how have you made your teammates take on those changes?
I tried to be more careful about what I said, because I think it's important. My rule is if something is offensive for whoever, I take that person as the thing that adjusts my behavior, because who am I to judge what offends you or whoever? So in that sense, I think it's very interesting to try to change how we talk or what we say, or even think, why is it okay to say things like that on a whole more cultural context? But yeah, because just to think about the, okay, in the database industry, the whole slave versus master, put it out. And just think about the conquerors versus settlers. We are so nice. We just came here to. So the whole narrative you can put around it is completely different. The same about this blameless post-mortem culture versus who did it, who is at fault. Like when people say Git blame, that's already, it's just not Git archaeology, I don't know, or whatever it is. I don't know. I saw a different joke on Twitter, but I don't remember the exact, punchline, yeah. Anyway, I don't know if there are.
All right, let's thank the speaker.
Thank you.